Hello everyone. In this video, we are going to determine the domain and range of exponential function. Before we go through these examples right here, let's have a review on the different notation in writing for domain and range. We remember that in writing for the domain and range of a given graph, if the value is not included, we're going to use an inequality notation with no bar underneath, or we are going to use a parenthesis if we want it in interval notation. If the values are included, then we use a greater than or less than with a bar underneath. And we use a bracket if we want it in interval notation. Now, for inequality notation right here, we remember that for domain, this is read as x is greater than or equal to a, or x is less than or equal to b, where our a here is the leftmost boundary, while our b is the rightmost boundary. Now for the range, we have y is greater than a or y is less than b, where a here is the lowermost boundary of the graph, and b here is the uppermost boundary of the graph. Now, if we want it in interval notation, now please take note that this is not an ordered pair notation. This is for domain and range. So this a and b can be placed either inside a parenthesis or inside a bracket. Now, for domain, we are referring the left side right here, it's either a bracket or parenthesis. This would represent the leftmost boundary of the graph, while this will represent the rightmost boundary of the graph. Now, if we have a notation, interval notation for range, this would represent the lowermost boundary of the graph, and this would represent the uppermost boundary of the graph. Again, the bracket represents if the values are included, and the parentheses represents values that are not included. Okay, going back to the examples right here, let's take this first one right here. Now, please remember that for exponential function, the asymptote is horizontal. So that means this broken line right here is the asymptote for this graph right here. And remember that an asymptote is a line or a curve where the graph gets closer and closer to it, but it's not gonna touch it. So although in the picture it looks like it's touching it, but this is actually an asymptote. It only gets closer and closer to it, but it's not gonna touch it. So let's take the domain here. So when we say domain, we're referring to the leftmost boundary and the rightmost boundary. So in this case right here, if we go to the left side, it goes all the way to infinity. And on the right side, it also goes all the way to infinity, although it's slowly going towards the right side, but it's going fast up, but then it's still going to the right side all the way to infinity. So then we can go ahead and say that our domain for this function or for this graph right here would be all real numbers. Okay, so if we want to write this in interval notation, this would be negative infinity and then all the way to positive infinity, and it's gonna be a parentheses. So the leftmost boundary would be negative infinity and the rightmost boundary would be the positive infinity. Now let's look at the range. So remember that range is the boundary, would be the lowest boundary and the uppermost boundary. So if we look at the graph here, we start from there. If we go down, then that's the boundary, which is where the asymptote is, which is where the horizontal asymptote is. So therefore we can go ahead and say that our range here would be anything that is greater than, because it's directed upward here, so anything that is greater than -4. So I can go ahead and write y is greater than -4. Now please remember that this is, so in this inequality, it doesn't have a bar underneath because -4 is not included. This graph will not touch -4. It only gets closer and closer to it, but it's not going to touch it. The other way to write the range for this would be y is greater than -4. So it's going to be greater than -4, but is less than positive infinity. So if it's infinity, we are going to use less than, or we're going to use an inequality with no bar underneath. Now, if we want to write this this in interval notation. So the lowermost boundary would be -4, and then the uppermost boundary would be all the way to positive infinity, and these are both in parentheses since these values are not included. Okay, so these are their values. Now, please remember that for exponential function, because in some cases there are graphs that the asymptote is not drawn or is not given to you. Now, please remember, as you can observe here, the equation for the asymptote is actually y equals -4. So this is the asymptote. So if the asymptote is not written in there, you can go ahead and draw a line on y is equal to k. So whatever that k value is. Okay, now let's try this next one right here. So for the domain, again, if we say domain, we're looking for the leftmost and the rightmost boundary. So in this case right here, if we go to the left side, it's going to infinity. And if we go to the right side, it's going to infinity. So then we can go ahead and say that the domain for this would be all real numbers. Okay, now if we look at the range, again, the range would be the lowermost boundary and the uppermost boundary. So if we look at the lowermost boundary here, this is going all the way to infinity. That's the arrow is pointing all the way to infinity. Now, if we go to the uppermost boundary here, the boundary is on 5. Because this is the asymptote. Now remember that that's a positive 5. So the equation for this asymptote is y is equal to positive 5. Right here, y is equal to -4. So then we can go ahead and say that our range here would be anything less than 5 because it's directed downward. Again, 5 is not included because this is an asymptote. An asymptote is a line or a curve where the graph gets closer and closer to it, but it's not going to touch it. So then it means that our 5 is excluded, or it's not included as part of the range. So we can go ahead and say y is less than 5 would be our range. Now the other notation for this would be y is greater than -infinity, that's the lowermost, but is less than 5. So that means 5 is not included. Again, these are both not included. So we're not going to put the bar underneath the inequality. Now, if we want to change this in interval notation, the lowermost is -infinity, and then the uppermost boundary would be 5. So this is in interval notation. At this time, I would encourage you to pause this video and try these problems out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problems here. So the domain for this would be, since we go left and right and we look at the boundary, it doesn't have any boundaries. So which means that this is going to be all real numbers. Okay, now let's look at the range. Now, if we look at the range, again, our asymptote is located on 2. So this is y is equal to 2. Now, again, please remember that if the asymptote is not given, you can draw a line in there. But in this case right here, y is equal to 2. So then we can go ahead and write the range as So these are the notations for range. They all mean the same thing. Did you get the same answer as this? Good. Perfect. Now let's move on to the next problem right here. So again, our domain for this will be all real numbers. So this is going to go to the left side to infinity and to the right side all the way to infinity. So domain would be all real numbers. Okay, now looking at the range, we can conclude that this is our asymptote. Our asymptote is on y is equal to -6. So then we can go ahead and write the range as So these notations right here mean the same thing. So this is the range for this graph. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!